Welcome back. What I'd like us to do right now is try a handful of problems based on intersection and expected value. All right, what I'd like you to do is I'm going to put up 5 problems. I'd like you to try the problems first, and then once you're done trying them, come back to the video and check your answers or get some hints on how to do them. All right? Your first question is, what's the probability of getting a 5? And I'm going to assume we're going to be working with a deck of cards. So what's the probability of getting a 5? Number 2, what's the probability of getting a red 5? Number 3, what's the probability of getting a black card and a face card? Number 4, what's the probability of getting a black card or a face card? And number 5, let's say that face cards are worth 20 points and it cost 5 points to play. Is it worth it? So in other words, in the long run, will I come up with more points than I started with? All right, let's go ahead and take a look at some of the answers. So looking at number 1 was the probability of getting a 5. So if you need to, go back and look at your deck of cards sheet that you should have gotten in class. And if you look at the number 5, there are 4 ways to get a 5 out of 52 cards. So 4 out of 52, or this could be reduced to 1 out of 13. Number 2, what's the probability of getting a red 5? That's the same thing as saying getting a red card and a 5 card. So both things have to happen at the same time. So that's going to be, if you look at your picture again, there are 2 ways to get a red 5. 5 of diamonds, 5 of hearts out of 52. Or 1 out of 26. The next one is a similar question, but I'm going to do it a little bit different so that you could see this could be done differently. So number 3 is the probability of getting a black card and a face card. So if I look at all the possible black cards that there are, half the deck is black, half the deck is red. So I know the probability of getting a black card is 1/2. And then the probability of getting a face card, if I count up all the face cards, there's 3 in each suit. So 3 times 4 is 12. So there are 12 out of the 52 cards. I'm going to go ahead and multiply this together. So it's going to be 12 over 104. And that reduces to 6 over 52. Now, I'm going to pause right there because that's what you might have gotten. Because if you think about it, if you pull up your sheet, there are 3 face cards that are clubs, 3 face cards that are spades. So that's a total of 6 out of 52. And in fact, it's probably better not to reduce them because this kind of tells me a story right here. There's 52 cards, 4 of them are 5s. There's 52 cards, 2 of them are red. There are 52 cards, 6 of them are black and are considered face cards. All right, next one, number 4. What's the probability of getting a black card or a face card? So this is the union situation. This is where I've got to consider all my black cards and I got to consider all my face cards without double counting them. So I'm going to use a formula on this one, and then I'll just show you how to do it without using the formula. So the formula says this, equals the probability of getting a black card plus the probability of getting a face card minus the probability of getting both. So the probability of getting a black card is 1/2. The probability of getting a face card is 12 out of 52. But then I've got to consider the overlap. I don't want to count the black cards and face cards twice. So that's where I've got to subtract off the 6 over 52. And this is probably better, it would have been better if I left this as a fraction because then I would have had it, or not a reduced. So half the cards are 26. So I'm just going to change that to 26 over 52. Now I have a common denominator. So 26 plus 12 is 38. 38 minus 6 is 32. So 32 out of 52 cards are black or they have a face on them. I could sit here and count them. I'm going to pull in a little, so remember the number 32. I could count that. So right here, these are the black cards, so I could just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Plus I got to count these. 27, 28, 29, 30, 31, 32. So these are all the black cards, and these are all the face cards. So now I could, it's just like this little L right here. So again, that was 32. Voila. That's what I got mathematically. So if you don't want to sit there and count them, you can use the formula to get your answer. All right, finally, our expected value question. So number 5. So face cards are worth 20 points. So what's the probability of getting a face card? Remember, that's what I need to have. I knew my points were 20, and then the probability of getting that, well, there are 3, 6, 9, 12 face cards out of 52. That's the probability of getting a face card. So remember, expected value is calculated by taking the probability of my points times the value. So actually this is the value. So 20 points times the probability. Well, there's another situation. I could get no points. So I don't need to write it, but I just want to show you that's where the rest of the probabilities would be. So this would be 40 out of 52. This is just going to be 0. So the expected value is going to be 20 times 12 is 240 out of 52. I'm going to need a calculator to figure that out. So 240 divided by 52 is 4.6. About. We'll go 4.62. We'll round it. And we'll make that approximately. So cool. I'll get about 4.26 points. However, it cost me points to play. So if we look back at the original problem, it cost $5 to play. So I've got to subtract that off. So I might get 4.62 points, but I got to take off the 5 points that I originally had to pay to play. Right, so this is how much I would win, but this is how much it cost. So 4.62 minus 5, oops, minus 5 is negative 0.38. So I would lose 0.38 points per turn on average. So that's, I would expect to lose that on average. So yeah, this is no good. I'm going to lose points on this game. It sounded like it was going to be good, but don't forget, it cost me to play. All right? If you have any other questions, be sure and ask your teacher. See you next time.